Now I want to give you an alternative form of the definition of the derivative. This is completely equivalent to this is completely equivalent to the uh, the definition we saw earlier that involved h approaching zero. It's just a different way, really, of expressing the exact same geometric concept. If you recall before, what we did was we said, if I have some point A, then I can simply define the distance h that's going to zero and call that a plus h. The point of letting h approach zero is that these two points on the x-axis are getting closer and closer to each other just by letting h drop to zero. Well, the other way you might do that is treat a as a fixed point and then define a variable x and simply let x get very close to a. How do we express that in calculus? We say, quite literally what I just drew there with the arrow, we say x is approaching a. So if that's the case, then we have our 2 points on the curve, x f of x and a f of a. The slope of the secant line connecting them is f of x minus f of a over x minus a. So um, so if we let that expression, if we evaluate that expression, the limit of that expression as x is approaching a, we would just for the same reason get the slope of the tangent line. So this is just another way of thinking about the definition of the derivative, and this is considered to be an alternative form of that expression.